Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And I'm Viraj. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Well, thanks for taking care of that for us, Viraj. How are you feeling today?
Great.
You feeling great? You had a good day at school?
Yeah, I had a really good day at school.
What kind of things did you do at school today?
Today I had gate, so we learned how to add and subtract integers.
So explain to me what an integer is for students that might not have ever heard of that before.
So an integer, it's like a number, but you need to put a positive sign and a negative sign. So if you want to subtract, you could even do this. Positive 8 plus negative 8 equals 0.
So I have positive 8 and negative 8. I put them together, I end up with 0.
Yeah.
What if I have negative 8 and I add negative 8? Am I still at 0 because they're
No,
like
you
negatives?
get to 16 because both of the symbols are same, so.
What if I had negative 8 minus negative 8?
Negative 8 minus negative 8? You gotta add them because they're still negative.
So what's it going to be?
16 negative.
Oh. So if we have negative 8 plus negative 8, it's negative 16?
Yeah.
And if I have negative 8 minus negative 8, it's still negative 16?
Well, I'm getting confused.
That's okay, because we're going to help you out with that. I just wanted to make sure, because you're doing pretty well right there. So you did integers, so that's kind of a big thing. Have you done that
No, this
outside
is my
of
first time.
today, or just you kind of started it today?
I just started it.
All right. So what about any other topics in school? Is there anything that you kind of really liking so far this year?
Liking? One good thing about school I like is all the activities. Like I get to do valet, peer tutoring, and all that stuff.
So valet. So you're driving people's cars into the parking lot for them? You're parking people's
Tip you
cars?
well?
Not that,
Valet.
not that type. I open their cars for them.
Oh, all right. So you're doing the nice thing, right? You're
Yeah.
helping kids out of their cars and you're helping them get safely to school.
Yeah.
Well, that's a nice thing to do right there. And this is the first year that you've been doing that, or you've been doing it before?
Oh no, this is my first year.
Well, now that you're in 5th grade, you're getting a little bigger, you get some more responsibilities and stuff going on, right? All right. So what kinds of things are you involved outside of school?
Outside of school, I do soccer. I like to play video games a lot, and yeah.
You play soccer video games?
Yeah, I play.
Oh, okay. Okay, usually there's not a lot of crossover there, but that
Now,
helps
that
out.
soccer video game, that used to be when you and I were a little younger, called Pong, I think, right? You were just going, the chuckles from the background,
I am
right?
not going to put myself into this
They
conversation because I'm
remember
not going
that,
to date
right?
myself
Well,
any
hey,
further
easy,
here.
son, you're not as young as you think you are.
We have
I'm
some
sure you
sticks that we
remember that
use.
game.
It's more than just
Anyway,
one.
that's a little something you can look up sometime. You can laugh about it when you see it. Anyway, are you ready to help me out with today's social media problem of the day?
Yeah, I'm ready.
All right, let's take a look at it together. It's up here. It says problem of the day. All right, now I see apples and bananas and I see some numbers. So tell me how you think you want to go about solving this problem.
Apple plus apple plus apple equals 15. Well, we could just divide 15 by 3, which would be 5, so.
So an apple is 5?
I think, yeah.
All right, so what do we do with the next one? Then we've got 5 plus bananas equals 17.
5 plus, we could do, 5 plus 7 is going to be 13, what am I saying? 12, and then add that by 7, it's going to be 19 though, so you could add 1.
So you're doing a lot of thinking. I like it because you're thinking out loud, which is what we like. So in the first one, you said that an apple was 5 because you went 15 divided by the 3 apples was 5.
Yeah.
So if we say an apple is 5, then we could subtract the 5 from 17.
And we would get 12, which would be divided by 2, is going to be A, which is 6.
Okay, so 6. So you think 6 is the correct answer because your logic makes sense, right?
Yeah.
We're going to take 17 minus the apple is 5, which means we have 12 left, which means the bananas are worth 12, which means 2 bunches would mean each one is 6. So therefore you think that A is 6. Now taking a look at the problem that we have with the 2 sets of bananas, and what does the question say? What does it ask us?
It's asking us what the banana is.
Right, so does it say what do the bananas equal or what does banana equal?
What does banana equal?
Okay, now that's something that you need to pay attention to because what does a banana equal is different than what does a bunch of bananas equal. Does that make sense to you?
Yeah.
And a lot of kids will do this problem quickly and they will go, oh, I can do this, bananas are 12, so it's going to be 6 because there's 2 groups. But is there any other possible answer that we could come up with, do you think?
I mean,
Now 6 makes sense, right?
yeah.
Why do you think 2 is up there?
I mean, they could think that the apple's gonna be 10 and then 10 or 15, then they could just add 2, which would be equals 1 is banana.
Oh, okay, they could, right?
Yeah.
That's one way of looking at it, right? What about 3? Is there any reason why you think 3 might be up there?
3? I don't know.
Okay. What about 5? Any reason why you think 5 might be up there?
I mean, people would think that the apple is 7, so they would add 5 plus 5, which is 10, plus 7, which is 17, so...
Or they might go, the apples are 5, so I'm going to just go 5 because I'm not paying attention. It wants a banana. So here, I'm going to help you out with this one a little bit. How many bananas are in each little group in that equation?
3.
There's 3. Now, you said that a set of bananas is worth 6. Okay? So if a set of bananas is worth 6, 3 bananas are worth 6. And they want to know what 1 banana is worth. What is 1 banana worth if 3 bananas are worth 6?
I say 2.
You think 2? All right. Now, at the beginning, when you were going kind of quick and you were rolling there, you said 6 was the answer. But now you think,
Oh,
you think 2 might be the answer now?
yeah.
All right. I want you to feel good about what you're doing here, right? I mean, just don't go, hey, old man, because you said 2 is whatever, and 6 might be it 2. Which one do you think it is? Do you think the banana, 1 banana is worth 6, or do you think 1 banana is worth 2?
I think 1 banana is 2.
All right. Well, let's take a look. You ready to take a look?
Yeah.
All right. Let's find out if indeed you were correct. There you go. See, the answer was 2.
Yay.
Nicely done, right, dude? So sometimes we go kind of quick at them and we look at them and we're like, yeah, it's 6, right? And there's a lot of people that put 6 because they did exactly what we did. We were looking at it and go, oh, 12 divided by 2 is 6 and we're done quick. But then they get it marked wrong and they're, how can that possibly be wrong? But if you look closely at it, it's 3 bananas and they're asking what 1 banana was. So nicely done, Viraj. So you're a 5th grader at Stockdale Elementary.
Yeah.
All right. You ready to do some difficult math today?
Yeah, I'm
All
ready.
right. Well, you know what? But first, before we do any of that, we're going to take a look at today's Math in the News. Well, with us today from all the way across the country in Corning, New York, from the Corning Museum of Glass is Helen. How are you today?
I'm wonderful. How are you doing today?
I'm excellent. I do really want to thank you for taking some time to join us this afternoon because I think this is very cool. The Corning Museum of Glass is well known, and what you do there is essentially take a product and transform it. So talk about, first of all, what is glass and how is that created?
Yeah, so I'm here in the Corning Museum of Glass amphitheater. It's one of the places that we do daily demonstrations with glass blowing. But what is glass? It really is a non-crystalline solid. It has molecules that are just sort of all jumbled up, so it has qualities of both liquids and solids. But if you're looking at glass, it really is a solid. Solids like ice and quartz have molecules that are arranged in very regular, predictable patterns, and that was something we call a crystalline structure. So when you're looking at quartz, for example, you go to break it, it'll cleave really cleanly along that clean line. But with glass, those molecules are randomly moving around, and so as they seize into place, they seize into very unpredictable, jumbled, random ways. So that's why it's called a non-crystalline structure. It doesn't have grid patterns to that, its molecules. So plastic, wax, rubber, those are examples of other non-crystalline structures.
So we know that glass is made of sand, but how do you take that sand? Like, how hot does that have to get in order for you to be able to work with it then?
Yeah, so glass is made of sand, but it kind of depends on the kind of sand and the things that you mix with it to create the types of glass that you want. So we'll talk a little bit about soda lime glass because that's the most common type. But even sand by itself, sand can have a lot of other components with it. So if you go to the beach and you scoop up some sand, you're going to see little rocks and other things that really wouldn't make nice glass. So we're looking at the most refined version, and that's going to be silica sand. Now, silica sand, in order to get it to melt, takes about 3,000 degrees, just above. So that's pretty high. So we tend to add a flux. Flux is lower melting temperatures of materials. And so with our sand, we start out with the high quality silica sand. It needs to be at least 95% silica to be able to even have it melt into glass. And then we add a flux like soda ash. And soda ash will lower that melting temperature down to a much more reasonable 2,000 degrees rather than 3,000. And then what you add to that mixture as well would be limestone. And limestone is going to be a stabilizer. It's going to keep that chemistry from melting in water or being affected by the environment. So sand would only be about 74% of that percentages of the total ingredients, but you vary those. You change the flux that you use, that'll change the properties of the glass. So things like boron added would give you a porous silicate glass, which doesn't expand and contract. Or lead is another addition that can be added, and that adds a beautiful clarity to the glass. So lots of different ways you can mix materials together to create various glass for certain products.
Okay, so the kids will be able to understand the qualities of glass and the different materials you're putting in there. How do you affect the color? Because kids will associate glass in the different colors, but how do you get certain colors of glass?
Yeah, so color is generally imparted from some sort of metallic oxide. Really, most things on the periodic table. So if you're looking at iron, that's going to give you green glass. I actually brought a couple little things with me here to show you. But iron oxide, it looks very red in the bottle, but once it's melted in with glass, it gives us this beautiful light green color. So it's not going to work like paints will. You can't use a dye or anything that would end up burning up in the chemistry. So we're using things like cobalt for dark blue and copper for light blue color. So different metallic oxides mixed in with those raw materials of the silica sand, soda ash, and limestone, and they melt that into the furnace all as one, and that will impart color. But even the way you fire a furnace can change those colors slightly. So there's a lot of chemistry and a lot of perfect timing to get that perfect color.
Okay, so you were just talking about the furnace, and you said we need to get that to 3,000, and then by adding materials, you get it to 2,000 degrees. But other than the furnace or kiln that a lot of students would be more familiar with at schools, what are some other tools and techniques that you use on a regular basis at the museum?
Well, here at the museum, we mostly use our furnaces, and that's what's right behind me, the big gray thing. So that's about 1,000 pounds of glass. So that's what we use for our 2 daily demonstrations. But even within the demonstration, we use torches to help melt glass and be very specific in the way that we can heat in very small areas. And we also have a demonstration of flame working here at the museum. So they mount a torch to the table and then introduce tubes and rods into that torch head to be able to melt and make small objects or hollow objects from there. So you can make hollow objects in kilns, as you mentioned, doing things like casting and fusing, or you can use the inflation and making glass blown objects, or work on the torch to make both solid and hollow objects.
All right, well, Helen, we've got the basics now, but then what we're going to do is we're going to move into another area. But as far as the Brilliant Color exhibit, can you tell us a little bit about that?
So we have lots of resources here at the museum, and right now we have a beautiful show called Brilliant Color. And in the late 19th century, early 20th century, there was really a boom in color that was happening around the world. And that really was correlating with the invention of synthetic dyes. So prior to that, it was a lot of natural materials that would create various colors in home goods and fabrics and things like that. Well, in that late 19th century, we start to see synthetic dyes take over, which encouraged a lot of industries to start adding more color to their repertoire. And of course, glass definitely wanted to be involved. So this brilliant color show really talks about glass chemistry, the artistic developments that happened around the time. There's examples of batch books and things that are just such a rare thing to be able to see. So it's a beautiful show. Lots of beautiful objects, very unusual glass objects and combinations of colors and new developed chemistries and things like that. But yeah, it's definitely a great addition to our museum this summer.
So the Brilliant Color exhibit goes until January, and hopefully you can see Helen when you're out there at the Corning Museum of Glass. We'll be back with more right after this. Our mathematician of the day is Charles Dodgson. And a lot of you might go, I've never heard that name before. But I'm sure you've heard of Lewis Carroll, the author of Alice in Wonderland, Alice in the Looking Glass, things like that. Those books are very famous, and that was his pseudonym for Charles Dodgson, same person as Lewis Carroll. Queen Victoria loved the Alice in Wonderland books. She demanded that she have everything that he had written. She didn't realize that they were mostly math books. He also loved doing logic problems. We're going to take a look at a logic problem right now. Assume each of the following statements is true. Use all of them to reach a logical conclusion. So what I do is I often tell students is start where something is by itself. So by itself means there's only one mention of it. So if I get good grades, so we're going to look and see if there's any other mention of grades, good grades. And I can see that good grades is right here. Okay, so that evens itself out, let's say. Next, I go to college. We see if there's anything else pertaining to college. I go to college. That evens itself out, right? They cancel out. That's just one way of looking at it right now. I get a good job. I get a good job. I make a good salary. I don't see another good salary right there. So this one right now is by itself. If I stay home, I stay home. I study, I study. If it's raining, and there's no other rating. So now what I'm going to do is I'm going to look, all right, good salary is at the end, and raining is at the beginning. So if I want to go in order, you obviously want to start with something at the beginning that is by itself. So I'm going to go, if it is raining, so I'm going to start with the number 5. If it is raining, then I stay home. So let's find out if I stay home, what happens. Okay, if I stay home, which is 3, right, then I study. So we ended with study, so I have to begin with study, which is right here. If I study, then I get great grades, so there's 6. So I ended with grades. I go to a beginning statement that begins with grades. If I get good grades, then I go to college, 1. College is where we ended, so college is where we need to begin, right here. If I go to college, then I get a good job, that was number 4. Good job is where we ended. If I get a good job, then I make a good salary. 2 is the last one, and good salary is what we want at the end. So taking a look at these 6 statements, it would go in order of 5 if it is raining, because raining is all by itself. It's at the beginning of a statement. That's where you want to begin. The only other thing that was separate by itself, good salary, it was at the end, so you want that at the end. And we can see that we started with 5 and we ended with 2. So the simple order is 5, 3, 6, 1, 4, 2. You can take a look at that. That's one way to solve logic problems, all courtesy of Lewis Carroll, also known as Charles Dodgson.
Did you know that the number 16 is the only number that can be written in a reverse power way? Leonard Euler proved this with the equation 16 equals 4 to the second power, which equals 2 to the fourth power. Now you know.
Did you know about the number 16?
No, I didn't.
Well, there you go. You can go back and show classmates that. You can show your teacher that tomorrow about 16, all right? A reverse power. So Viraj is a 5th grade student from Stockdale Elementary. You like soccer, right?
Yeah.
That's why I brought the soccer ball in for you, right? You're kind of comfortable with that, right?
Yeah.
And you score a lot of goals, right? You're the leading scorer?
No, I'm the mid.
Oh, you're the mid. All right, well, good.
Fielder. Yeah, right.
So are you ready to do a little math involving a soccer ball?
I love to.
All right, leave this with me, young man, and you and Devin are going to head over to the board, and we have a truncated icosahedron. That is how you classify a soccer ball mathematically as far as its shapes and what it is made of. So there are 2 shapes, Viraj, that make up the soccer ball. Are you able to look at that and tell what the 2 shapes are?
Pentagons and hexagons.
Right, we have pentagons and hexagons. So here's what I would like you to do. When you put 2 of those shapes together, if you have 2 edges, and you put them together as you would a soccer ball, they sew them together, and that makes 1 line. How many lines does it take to make the soccer ball? So how do you think you want to figure this out?
I'm probably gonna count up all the hexagons and pentagons first.
Well, you and Devin go to it. Figure it out.
Should we split the work here? Do you want me to count one, you count the other?
Yeah.
Okay, what would you like me to count?
You should count the pentagons.
Okay, I'll take the pentagons. I can just label them just to be clear so I don't lose track of them. So I'm going to go ahead and do that. While I do that, do you want to take yours and count the hexagons here? So you start on that side, we'll cross over, and we'll keep going from there, all right? So you start labeling and counting the hexagons, and I'll go ahead and start counting the pentagons, all right? I'm at 5. Okay, we may have to do a switch here. Ready? And swap. I was at 9, 10. Okay. So I ended up with 12 pentagons. How many hexagons did you end up with?
I got 20.
All right, great job, counted them both. That's the first step I know you wanted to mention. So let's go ahead and figure out what would be next there. What do you think would be the next step?
I don't know.
Remember what we're trying to figure out is how many lines are there overall on a soccer ball, essentially, right? Once we connect these and sew these connected edges together, right?
So I would probably multiply 12 by the pentagon, which has 5.
Well, why don't we go ahead and do that, all right? Go ahead and take your stylus there, multiply 12 by 5, like you mentioned.
I mean, 60.
Yeah, so 12 times 5 is 60. Okay, so that tells us overall how many edges there are on all of the pentagons combined. Mm-hmm. Is there anything else you think we may have to do then? So let me ask you this. Are there any lines? Because if we presume that all of these lines of the pentagon are matched up by a side on the hexagon, are there any other lines that we're forgetting about?
We're forgetting about the lines that connect to the hexagon's lines right there.
Okay, very good. So we have to figure out how many of those lines there are, right? So on your standard hexagon, how many lines are connected to other hexagons?
On the standard hexagon, on this graph, there's about 3.
3, right? So anything right here.
Well, an easy
here,
thing might be
here,
instead of
right
counting those, because when you put it together, there's going to be more connections than what you're looking at.
Yeah.
So what you did is you took the pentagon and took 12 of them by 5 sides and got 60. Do the same thing with the hexagon.
Oh, so 6 times 20, it's gonna be 120.
Okay. So we have 120 sides combined of all of our hexagons. And we have 60 sides combined for all of our pentagons.
Mm-hmm.
So how many sides altogether do you have now?
180.
All right, so you might want to write that down so that you don't lose track of what you're doing here. So you've got 180 sides. Mm-hmm. When you put the 2 shapes together, how many sides are meeting?
2 shapes together? Well, about 1.
Here, don't. Okay. If you take the edge of one and the edge of another, how many edges are coming together?
1, 2, 3, 4, 5. For a hexagon, there's 1, 2, 3, 4, 5, 6.
Okay, but I just want one edge of it. So just take one edge of the hexagon. Mm-hmm. And how many edges is that touching on the other shape?
1.
One. So together, two edges make how many lines?
1.
Okay, that's the information you want. If we have 180 edges, how many lines will there be?
We got to divide it by 2.
Keep going.
So 180 divided by 2 is 90.
So if you wanted to put a soccer ball together that was laid out in a net like that, how many lines would you have to stitch together?
We would need 90 lines.
There you go, right? So that's a perfect math problem for you right there. So you will be able to tell everybody on your soccer team there are 90 lines that you have to stitch together, put together to make that soccer ball because you saw it all laid out as a net, which is what that figure is called. All right, nicely done. So for a great problem today, you've got yourself a pass to go see the Bakersfield Condors. So a little ice hockey, somewhat like soccer on ice, I guess you could call it like that. But anyway, that season is about to start October 18th, and it is a full-packed weekend that the Bakersfield Condors will have in town. We'll be back with more right after this.
You are looking at the 1987 Kern County Math Field Day Mancala Champion. Yes, that's right. It's been going for a really long time, and I am old, but not as old as this game. Originally developed around 6,000 to 7,000 years ago in Africa, boards have been found as old as 1400 BC. So this game, which many of you may have already played and already know or seen in your classroom, is just stones or seeds or beans or anything of that variant that you can find. And the boards look like this for if you're playing it with 2 players. This is a 4-player board right here as well. Now, most of you may know some of the rules, and if you don't, the rules are very simple. You collect all of your stones or beans from your side. This is my side, and I'm going this direction, and I'm going to put 1 in each until I get here. Now, if I have more, I'm going to go around the board. If my last one lands here, I get to go again. So that's a really special space. I get to go again. And so I can go again, and this is a very common open move. And if my last one lands in an empty space, then the one across from it, I get to take all of theirs as well, and I empty that out over here. Now, of course, it's whoever collects the most. Over here is the winner. Now, as I said, one of the most common openings is to start right here from the 1, 2, 3, so that I can do 1, 2, 3, and I get to go again. However, that is not what won me the championship in 1987. There is another opening that actually is more beneficial, and while I'm not going to tell you what it is, if you spend a lot of time playing this fantastic game, you can maybe discover it yourself. Try to play both defense and offense and see how far you get.
And with us right now, we've got Helen, a gaffer from the Corning Museum of Glass. And Helen, before we go any further, what is a gaffer for students that don't know?
Yeah, a gaffer just usually refers to the person who is making the object at the time. Historically, it was referenced the senior member of the team who might be running a production team, and sometimes has connections to grandfather with that, but not all gaffers are grandfathers.
All right, so we're going to talk about how glass work is created. So explain a little bit of the difference between, because some students have seen glass blowing, possibly at different events, versus using a torch.
Yeah, the biggest difference would be the furnace. The furnace here behind me, this would be a big tank of glass in the bottom half. It holds molten glass at all times. So the gaffers would go in and just wind a little bit of glass onto the end of a hollow or solid pipe, and then you can manipulate the glass further using tools and heat and inflation. But on a torch, you don't actually have a tank of glass to work with. They just mount a small torch on a table. And so you have to buy all your glass pre-made. So we buy it in big rods or big hollow tubes. And then you can introduce sections of that tubing into the flame to create the heat. So you're not getting the entire mass of glass hot at the same time like you would in the amphitheater or in the hot shop while you're working.
All right, so I know it's probably a lengthy process, but can you give us a condensed walkthrough of the process of creating a glasswork?
Yeah, it all starts with our first gather. So gathering is both the action of pulling glass from the furnace, and then also we talked about the amount of glass on the end of an iron as being a gather. So you just need to wind a little bit of glass around the end of an iron, make sure that it's the right shape and temperature, and if you add air pressure into that blowpipe, you blow through that soft material and create a hollow object. So you're generally finishing the bottom half of an object when it's on that blowpipe by manipulating it with tools, using things like gravity. You're constantly turning the pipe because it's a liquid material. It's going to want to drip to the floor if you stop turning. So you're really looking at a lot of physics, a lot of heat transfer to make these objects come to be. Then once you get the bottom half done, you attach a second rod, what we call a punty. So it's just a small bit of glass on a solid rod, and you break it free from that original blowpipe. It flips the piece around, and then you can work on the top half.
Okay, and I know that there are a lot of colors involved in this, and we've spoken a little bit about the colors before and where they come from. And for them to be pleasing to the eye, you want them aesthetically looking nice, but why do certain colors work better together than others?
Yeah, when we're looking at using color, the biggest challenge is really in how soft or how stiff they are. And some of the softness and stiffness comes from the chemistries of the glass, and some of it comes from just being light or dark. So if you're looking at certain materials having different melting points, that might create a softer or a stiffer color. But we're looking at, say, black and white. Now, black glass is going to be made of manganese. It tends to be a really soft glass. And part of that is because it's absorbing the heat energy as it's being melted. So it'll make you really warm if you wear a dark shirt on a sunny day. So those kind of principles apply in the hot shop. Then when you look at white glass is going to reflect that heat energy. And so it's going to take a little bit more to get that to be actually hot. So if you were to put black and white stripes on a vessel and you go to inflate it, well, the black parts are going to want to move faster than the white parts. So that can be challenging to keep those temperatures in just the right balance to be able to make a piece and make those stripes look even in the end. Okay. So it's just really learning the different colors, how they act to heat, and being able to work faster or slower depending on how those colors react to the heat.
So that's just years of experience and trial and error, experimenting, things like that. So we've heated it up. We've talked about how hot this gets, and it's constantly in motion, and you're moving it so it doesn't drip and just fall courtesy of gravity. So we've got it heated up and you're just about done. How do we cool it?
Yeah, and that's one of the most important things about making a glass object. You can make the most beautiful thing in the world, but if you just let it out to cool on its own, it's not going to survive that cooling process. And the reason why is most glasses have an expansion and contraction rate. As they heat and they cool, they're kind of expanding, contracting on a molecular level. So if you imagine a mug is going to have a thin sidewall and a really thick handle on it. So those things will heat, they'll stick, they'll melt. You make this beautiful mug, but if you let it out to cool naturally, the thin walls would be shrinking at a faster rate than the thick handle that's attached. So eventually they stress each other out and pop away from each other or crack. So we have to put everything that we make into a controlled environment and allow it to cool down really slowly so that the thick and thin, the big and small can all shrink at a nice even pace, and then the glass survives. So we call that the annealing process.
All right. Well, I know that you've got this other program, Blown Away, a show. So can you tell us a little bit about that and kind of where they are now?
Yeah, so Blown Away is a Netflix series. Part of this is a competition series that glassblowers compete with each other. It starts out with 10 and then dwindles down to the final 2. So Corning Museum of Glass has been able to take part in this Netflix series by supporting the final episode, the final competition between the 2 finalists. So our team goes up and helps. There's 3 of us that go up and help with that final exhibition. And then the winner is hosted here at the Corning Museum of Glass. So every year we've had an exhibition here at the museum that highlighted representing pieces from each contestant in that season. Right now we have season 4 up on display, but by the time this filming happens, actually, we'll be doing a retrospective show of Where Are They Now, including not just the winners, but also a lot of contestants for that show. And that show is going to open to the public September 20th. So well underway by the time we get this aired. So hopefully you can come and see that exhibition in person and a lot of online content.
All right, so Helen, if somebody wanted to learn more about the Corning Museum of Glass, is there a website that we can send them to?
Absolutely. At cmog.org, corningmuseumofglass.org. We also have a fantastic YouTube channel, which has thousands of hours of glass blowing, a lot from our team. There's also a lot of really interesting educational videos that are included in that YouTube channel. We have our Raquel library you can check out on our website. There's just so many resources. So hopefully, yes, reach out. Lots of things to learn and to see on our website.
Well, Helen, we certainly do appreciate the time. I know Mackenzie just had a fantastic time visiting with you guys, and some of the pieces that she brought back were just fantastic to look at and just amazing the process that you go through with all of this. So from the Corning Museum of Glass in Corning, New York, Helen, thank you very much. We'll be back with more right after this.
I come alive when I'm in orbit. It's like my being should be in space. Some people are born to be cowboys and ride a horse. I'm born to ride a rocket and be in space.
And there's NASA astronaut Don Pettit flying in to the International Space Station.
Science of opportunity happens on Earth. It happens anywhere. There are scientists, engineers, uber geeks that are tasked with doing some programmatic work in a laboratory. And because you are there and you get an idea. It's not on the script, it's not part of the program, but you get an idea. So the science of opportunity happens anywhere there are people thinking about advancing our knowledge. And the same thing happens on space station.
Wow.
That's good.
And then that rogue drop just came in from someplace and then it went someplace. Whoa, look at that.
I have been working with ice. I'm freezing and thawing these crystals and looking at the front between the different crystals. The kind of research we do on space station is research where gravity has a major factor in the equation. Looking at Earth's horizon and our atmosphere on edge is truly a unique sight. You can also point your camera more zenith and you could look at Milky Way structures. Images from space help tell the story to people on Earth that don't have the opportunity to go into space. So the photographs help complete the story of what it means for human beings to expand into space and expand into this frontier.
Oh, those crystals were pretty cool to look at. Did you like all that?
Yeah.
That's pretty sweet, huh? You like NASA at all? You like space things at all?
I love space.
Good. Well, you know what? I think actually you're going to be going down to NASA to the JPL in Pasadena pretty soon.
Yeah.
So that's a little something to look forward to. Seeing those crystals and things like that would be really cool to have like in a paperweight or something like that, right? You can kind of see them all the time. Mm-hmm. These are some of the examples of the glass that they were making at the Corning Museum of Glass. And I don't know if you remember, but when they showed the glass and then it being broken off, they put that punty in there first, right? Mm-hmm. And that punty mark, so can you feel that right in there?
Whoa, it's kind of rough.
Yeah, kind of rough right there, right? And that's what they do. That's where they cut that off, and that's that mark. Now that one was a little rough, right? So check this one out right there. See if that one feels the same way, or is it a little smoother?
It's so smooth.
It's so smooth, right? And this is a little different because they were talking about that show Blown Away. And this is one of those pieces that one of the people in Blown Away made right there. Whoa. So if you were looking at these glasses, is there one that kind of you look at and you're like, wow, I really like that glass more than the others?
This one kind of looks like it has a blob all over it.
Okay, so you like the look of that, right? Check the bottom of it, and can you feel or see the punchy mark?
I could feel and see the punchy mark. It's really rough.
Yeah, there you go, right? Okay, so this is something that you might do sometime, right? You're out, you're looking at things, especially in antique stores and things like that, or people's glassware stuff, right? You might be able to like, hey, you know, I'm just kind of curious, is there a punchy mark down there, right? And that's what that is, that little mark, that indentation down there. How do you think they make something like that? That's pretty fancy, isn't it? Something like that?
Oh.
Yeah, that is pretty fancy, isn't it?
Punchy mark? Oh, no punchy mark.
No punchy mark on that one, right? Because that's done a little differently with a mold, but then to get all of the little intricate design in there and things like that. So it's something a little different, huh? So pretty cool. So if you wanted to find out more about the Corning Museum of Glass, there's a website that we have available, and it's going to be up on the screen right there. So you can find out about the Corning Museum of Glass and everything glass and everything they do there, the glass capital of the world. And I know that our producer, Mackenzie, had a great time when she was there. And I know people that travel all around the world at certain points because of activities they have going on at the museum. So we do appreciate their taking some time to share everything with us here on Do the Math. All right. Are you ready to do a little struggling today?
Yeah.
All right. You know that it's good to struggle.
Yeah, if you struggle, you learn.
There you go. See, I knew I had the right kid on today, right? You know that if you struggle, you learn. That is the most important thing that I wanted you to learn today, and you already knew that. So you're going to work with a program called Struggly. So you're going to struggle. Are you ready?
Yeah.
I know you are. Over to the board with Devin. So part of the Struggly games are that there are no directions. You have to figure out how to do this. And it will give you little prompts like, hey, you made a mistake, try again. Or great, you're on the right track and keep going. So you and Devin kind of figure out what you need to do here.
All right, so what stands out to you as far as what you see before we do anything else?
One thing that stands out, it's that piece right there. It has no number or color on it.
So tell me what you recognize these pieces as.
Dominoes.
These are dominoes. So when you see a domino, what do they generally feature?
The dominoes when you stand them straight and then you push them.
You can use them to stand them up, knock them down, and create a pattern. When we see dominoes, there are different figures on them, right? What do they tend to remind you of?
Probably dies.
Yeah, we have those patterns, those little dots, which are called pips. And any set of dominoes is going to have a series of different arrangements of those pips, right? So one side will have one, another. Some, they might be pairs where they have the same. But something that you don't see on a die, what you're seeing on some of these pieces, is that you have some sides where there is nothing at all. So that could represent almost like a zero value in some sense. Now, what else do we notice here in terms of what we're looking at?
There's an 8 right in the middle of the square.
So we have a square with a central square that has the number 8 there. Do we see anything else about this square? Tell me about the shapes that you notice around that 8.
They're rectangles.
They're rectangles. Do those rectangles look similar to anything else that we see here?
The dominoes.
So they seem to be the same size, right? What do you think is then the relationship between the dominoes and maybe the number 8 in the center?
My best guess is probably that you have to fill in these rectangles with the dominoes that sum up to the number 8.
So so let's see what we can do there to try to get some 8s. What could we try to arrange?
We could do about a 6 and 6.
Okay, go ahead and bring that 3 and 3 over. Okay, did you notice that as soon as you dragged it, it had some places to lock in some of the dominoes that you placed? Okay, so we have a 3 and 3 down there, south of the 8. Where else could we drag some dominoes?
To make 7, you could drag this right here.
Oh, now did you notice there? Okay, we seem to have placed some of those digits into a state of shock. Now we have some reminder there. It says try to turn some of the dominoes so that they match. So maybe instead of dragging it over like this, we have to kind of rotate it or tap it so that it falls along. Now some of them doesn't look like we can, right? Or there may be a different way that we can arrange it so that the dominoes are in a certain place. So if you notice, I can put it here and the one will go down this way, or I could put it here and the one will go there. Now when we did that, there was a face that showed up on two of them, one over here and one over there. So maybe that's a clue that we might have to avoid something. All right, so what else could we try then? Now, keeping in mind that 8 is coming into play, right? Well, let me ask you this. We have some 3s here. How could we get to 8 from 3?
From 3, we could add a 1 and 1, which would be 2. So
Okay. Oh, we have some gasps here again. And now we have some clues here. It says those two ends are not the same color.
they gotta be the same color?
So now when we match that up, that's really interesting because
That'd be 9.
the only thing, well, also, what do we notice about any of the green here?
Green, they're usually with a different color except that one right there.
Yeah, and all of the greens seem to be the same value, don't you notice, right? Anything green has to have what?
3.
3. So maybe if we're going to work around and figure something out here, we have to have some different colors. Otherwise, we're just going to end up with all greens, right? So we're still working with this 8. We don't have to match colors. Let's try something else, okay? What do you want to use as a starter piece, maybe?
Let's use 2 and 2.
2 and 2. Now, I feel like we're going to end up in the same issue, but let's try and see what happens. If we do 2 and 2, we're going to have to match one of the 2's to the end. So we have 2 and 5, 2 and 1, 2 and 4, 2 and a blank, 2 and 3. What would you like to drag over?
We should do a 2 and 2.
2 and 1. Now let's make sure that, the yellows match up here, right? So like this. Oh, we have a happy face there. That works out. Great. Okay. We have a blank, and we have another yellow. What piece could we drag over so that we match our colors and our numbers?
This one has to be white now, so we could do a 1 with the blank side.
Okay, let's bring the blank side so that it's over here, and then the blue is over there. Oh, bring it over this way. Over more. Like this, so that the blanks match up.
Okay.
Oh, that one has like 3 happy face hearts too. Okay.
Hey.
Now we're gonna need something that's gonna match up here and something that's gonna match down there.
We need this one right here.
This one right here, so we have the blue on top and the yellow on the bottom. All right, so everybody seems to be happy here. And now it has an option to verify. That just means to check to make sure that it's gonna be okay. Would you like to verify whatever that might be in regards to as far as our possible goal? Go ahead and click verify. A mistake. Think carefully about how to make the sum of your dominoes match the goal number. So I'm guessing that 8 is some sort of goal that we're trying to reach to. Now, is there a way that we can arrange some of these dominoes that we can get an 8 in any of these directions here?
We could maybe change the 2 and 2 with the 1 and 3 if we have one.
All right, well, there's a 1 and 3 up
Oh,
here,
wait.
but once we do that, we're gonna have to start switching some things out, right? Which is
So one
fine.
thing you guys might want to do is you started with the 2 and the 2 on the bottom, right?
There it is.
And
yeah.
how many was that all together if you have a 2 and a 2?
4.
So what number do you need in the last spot to make an 8?
We need a 8.
Well, you need 4 more, right? Because you already had 4, right? Each side will hold 3 different squares. Does that make sense?
Yeah.
Each side, it looks like, is going to need to equal 8. So if you start with the 2 and the 2 on the bottom, you're going to need a 4 at that far left side.
Right over here. So is there an instance where we can put a 4 that matches the 2 over here? Because we also have to make sure the colors match, right? And that's going to be a challenge we run into because the 4 is pink and it's not going to line up with the 2 in yellow. So we may want to step away from something where we have 2 yellows or 2 and work a little closer maybe to something a little smaller. So what's another domino choice we could try?
We could start with a 3.
A 3 and a 0.
All right, so here's what I'm going to let you guys do. I'm going to let you guys keep working on that, all right? Because you're struggling, aren't you? But while you're struggling, what is happening to your brain?
I'm getting new ways.
you're getting new synapses are firing off, right? So you're learning a lot while you're struggling. So I'm going to let you keep struggling with that right now. You and Devin keep working on that. We'll check him out right after this.
So that particular one cell is going to start dividing and growing because it's the only one that's going to be able to survive. And it's going to take over, everything else will die. So the fungi, they are able to release thousands and thousands, millions of spores. And these spores can be taken up by the wind and moved to very far away places. So the fungus is able to colonize totally different areas. For bacteria, the spores are a ways to protect it against extreme conditions. So certain bacteria, not all, what they do is when they get some extreme condition like extreme heat, they form this kind of like spore which protects their DNA against this harsh environment, and they stay like sleeping for sometimes decades or hundreds or thousands of years till ideal conditions occur, and then they just start dividing. In both ways, it's a way to propagate and survive. I think that is one of the worries about climate change. We're seeing these new organisms because we might not have seen them.
And currently there are no reasons for fungi to evolve to be able to withstand higher temperatures. But what if that were to change? What if, for instance, the world were to get slightly warmer?
Or things that have been there that have not really been active, but because now they're in an environment that is much more beneficial, they'll start dividing and growing. The fungi are everywhere. There are millions of fungi in the environment, but there are only about 100 that infect us. You have skin infections, so they land on your skin and they find a really nice moist area to divide and reproduce. And for the infections that affect your lungs or get into your body, you breathe in, and so they go into your respiratory tract.
And there are no treatments for this, no preventatives, no cures. They don't exist. It's not even possible to make them.
For fungi, they're called antifungal agents, so antibiotics that kill specifically fungi. And there aren't very many of those because the fungi, the cells are very similar to ours. So if you were trying to kill that cell, you're going to affect your own cell. You have a population of fungi. There might be one in that population that is naturally resistant to the antifungal agent. Then that fungus is unable to be controlled by the immune system, and it enters your bloodstream or it enters deeper into tissues and divides and reproduces. For you, the infection, how it appears to you, whether it be a fungus, a bacterium, or a virus, is the same. So the signs and symptoms that you see are almost identical depending on the infection. The fungal cells, when they get into your body, also grow and divide and cause damage. And underneath it all is how you react to them. So your immune system is trying to kill all these things that are trying to kill you or are trying to use you as a food.
Or blink.
Let's try that one.
All right, well, these guys are going at it again, and what they're doing is they're coming up with different things. So at first, they were looking at colors and trying to match the colors so that everything would match up when it was touching each other.
You have to have a 2
But
here.
now what they're doing is they need to get the sum of 8. So the 8 is in the center, and they need to put dominoes around it so that it all equals up to 8. So Devin and Viraj are working on this right now, and it looks like you guys just placed a couple of 2s.
Yeah.
And right now you have a total of 5.
We have 5, and we have one more domino to place. One of them has to have a 0 as a 1, but then it has to match what's already up here. So right now, what's up here is a blank. So if we put a 1 and a 0 here, that's only going to get us to 6.
We could maybe try 2 and 2, 4, 5.
Yeah. So, I mean, we could put it here, and that gets us to 6, and then we're going to need something up here. These have to match, so we're going to need something else that gets us 2 more, right?
Oh, We don't have a 2 and a blank.
Yeah, we don't, because we're already using one up here, right? So we may have to rethink this, right? Is there another domino maybe we can use to get us a little closer?
But maybe use the ones you had and move the 2 up.
Okay, so we're going to move this 2 up here this way then, or to the very top. Okay. Now if we do that, we still need to have a 2 up here, right? And we still have to have a 2 down here. So what could we try to help get us a little closer?
This time we could maybe try the 2 and 1, or we could go the same way.
All right, well, I think we're going to have to use both of these, right? Because anything else is going to get us over the top, right? So by default, we're going to have to use these here. But that's going to get us to 9 at this point, right? So we're still over by a little bit. We may be aiming a little too high with these 2s, or we may be in a spot where we only want to use these 2 together. And then see if that gets us around to the other side.
That'd be about 5.
So we're going to need 3 more somehow. Well, here's what we have, right? We can
But
bring
you guys
in
have about a minute and a half. How
another
about those?
Okay.
But now we have to match 2 blanks. So that still only brings us, to
get that out of
6
there.
here, right? Yeah, absolutely. So we have
So you
everything
got
fit.
6. Try the double ones.
The double 1 brings us to this point. Let's see if we can bring this over here. And that gets us to 7. Now, can we bring this over here and have it match?
Oh yeah. So these 2 match and those 2 match. So
All right. Well, let's verify and see if we can pull it off.
yay!
There you go. Check that out, right? So let me ask you something. Come here, Viraj. Did you struggle a little bit on that?
Yeah.
Right? All you had to do was get to 8, but there are no directions, right? So at first it was like, match the colors, right? And they were like, make sure the colors match up, right? So you're like, all right, well, we'll match the colors, right? And keep on going. There's other versions of the game where you have to do certain things, but you don't know exactly what you need to do until you hit verify, and then it starts giving you the clues, right? And it was saying, like, Yahoo, you made a mistake, right? So you want to make sure that using those mistakes, you're able to finally get down to the end right there. So you are now an ambassador for Do the Math. You understand what that means?
Ambassador is like a high person, so
It is a high person. It is a very high-ranking person, right? You are now an ambassador for Do the Math. So you know what you have to do about that? You know what you have to do for that?
what?
You have to let people know about Do the Math. Do you think you could do something like that?
Yeah, I can.
Yeah, there you go, right? You can talk to them about how you come on, you do some math problems, you learn all these different things and stuff like that, right? And as part of it, you have yourself, are you a master of this thing?
No.
No? Have you ever tried it?
I've tried it multiple times.
Many, many times, right? Well, I mean, a lot of us have tried it too. I know myself, I'm not a master of this. Devin, are you?
Never.
No, it's-
Never
see.
could get a feel. Even
But
a 2x2.
You're going to have this, you're going to be able to practice on this, and maybe you and your sister can work on it a little bit and do things like that, all right? So, did you learn a little something today?
Yeah.
All right. Did you have fun today?
I had a lot of fun.
Well, good. That's the most important thing right there, because you had a lot of fun because you were struggling, right? And you learned a little about something soccer, one of your favorite sports, right?
Yeah.
All right, there you go. Nicely done. Viraj, a 5th grade student from Stockdale. Thank you for coming in today. Thank you for struggling and having fun and learning and all that kind of good stuff. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.